Hello guys, welcome back, and in today's video we are going to talk about reversible reaction and equilibrium, and specifically in this video I'm going to talk about changing the effects of pressure. But first, let's take a look at what is a reversible reaction. So a reversible reaction, it is a reaction where the reactants can make products, but the products can also react together to give back reactants, okay? And that is called a reversible reaction. So if we look at this, when nitrogen reacts with hydrogen, we are going to get ammonia. And when ammonia decomposes, we are going to get back nitrogen and hydrogen. So this is what we call a reversible reaction, and this is a very common reaction in chemistry. So if we take a look at this, what we can see here is the arrow here, okay? So this arrow is called a reversible arrow, okay? Sometimes in exam they ask you about this symbol. So this reversible arrow tells you that this entire equation is a reversible reaction. And another thing that you should know is that the forward arrow represents your forward reaction, and the backward arrow represents your backward reaction or reverse reaction. So your forward reaction would be nitrogen and hydrogen reacting to form ammonia, and your backwards reaction would be ammonia breaking down into nitrogen and hydrogen. Now, let's look at what we call a dynamic equilibrium, okay? So there are three characteristics of dynamic equilibrium, but one of the things that you need to learn is that this can only happen in a sealed container. So if we take a look at this, right, I'm going to put this over here. Okay, let's say we have a test tube and I'm going to put in nitrogen and I'm going to put in hydrogen. So when they combine, they will of course form ammonia and H3. But if this is an open test tube, the ammonia can simply escape, okay? But only when this test tube is closed or sealed, ammonia can produce nitrogen and hydrogen again. And that is why for a reversible reaction to take place or a dynamic equilibrium to be achieved, it has to be in a sealed container. So one of these are the three properties that you are going to learn, and I'm going to tell you how each of it is going to work. So the first characteristic is that the total amounts or concentrations of both reactants and products are constant. Notice that you cannot write same or equal at all. Why? Because let's take a look at this. So at the beginning of the reaction, right, the reactants will be 100% because nothing has reacted yet, and your products would be 0%. So this is the situation here now, okay? So your reactants is 100% now, and your products is 0%. But once the reaction starts to take place, your reactants will start to fall, let's say to 80%. And at that time, how much do you think product will become? 20%, okay? So meaning that the reactants has actually dropped from 100% to, let's say, 80%. But your products has increased from 0% to 20%. So the reduction of reactants concentration and the increasing of hydrogen iodide, your product, will happen until they arrive at a position which we call a dynamic equilibrium. So at this place, let's say this becomes 40%. So naturally, your product would be how much? 60%. Okay, so at this point right now, if there is no more change at all, okay, at this 40% and 60% now, if there is no more change at all, what we can say is that at here, at this position, the dynamic equilibrium has achieved and the concentrations will remain constant at 40% and 60%. Why I cannot write that they are same or equal is that because it would mean that hydrogen and iodine will be always 50 and hydrogen iodide will always be 50. This is possible, but we cannot say it, okay? So the only correct word that we can use is constant, constant. And the characteristic too is that the rate of your forward reaction is equals to the rate of the backward reaction at equilibrium. Okay, your forward reaction and your backwards reaction is happening at the equal amount, and that the last characteristic is that both of them are happening at the same time. That's why I wrote it is occurring simultaneously. So in exam, if you are asked to write about characteristic features or properties of dynamic equilibrium, make sure that you are able to answer these three facts precisely. Okay? Alright, so the first thing that we can do to change, okay? Oh, sorry. So what can we actually do to change the equilibrium of a chemical reaction? We can try to do three things, which is changing pressure, temperature, or adding a catalyst. Okay, so right now we're going to look at the pressure aspect of it. Okay, so in order for pressure to be effective, there are two things that you need to satisfy. The reactants or products must be in the gaseous state. Okay, so they need to be in gaseous state because why? If they're solid or liquid, the pressure doesn't affect. And the total number of gaseous molecules on both sides of the equation must be different. What I mean by that is that when you're talking about pressure, you must talk about the number of molecules. So now I have 3 gaseous molecules on the left side and I have 2 gaseous molecules on the right side. So I can know that changing pressure will definitely have an effect. But how does it have it? Let's take a look at this. Pressure of the gas will always depend on the number of molecules. So if we say that, okay, these are 2 containers of the same size, and if I say that the left container has high pressure, what I mean is that I have a lot of gaseous molecules inside here. For the lower pressure container, I would have relatively lower gas molecules. So this is the first knowledge that you need to have. Okay, so if you try to increase the pressure of a reaction, the reaction will try to obtain the original equilibrium pressure. How will it do it? It will try to reduce the pressure, right? Because you're trying to increase the pressure. Let's say A plus 2B reacts to give C plus D is carried out at 100 megapascal. And if I try to use 180 megapascal, which is higher than my reaction pressure, the whole system will try to reduce the pressure because it wants to go back to the equilibrium. How can it do is that it can try to shift to the side with lesser gas molecules. Okay, so if we look at it here, we have 3 molecules on the left hand side and we have 2 molecules on the right hand side. So if I increase the pressure here, what will happen? The pressure will be reduced by producing fewer gas molecules. So the reaction will try to favor in this way because why? We need to lower the pressure again. So that is why the equilibrium will shift to the right side. Alright? So if you only need to remember one information and then you can try to write down the other on your own. Okay? So increasing pressure would shift the equilibrium to the side with fewer gas molecules, and decreasing pressure will shift the equilibrium to the side with more gas molecules. So what happens if the pressure of the reaction is increased? So to answer these kind of questions, if you see the word pressure, always remember to count your molecules. So we have 2 molecules on the left side and we have 7 molecules on the right side. So you're going to state that fact first, okay? So there are 2 molecules on the left hand side, or you can say that it is reactant side, or you can say that it is the backward reaction side, and we have 7 molecules on right hand side or product side or forward reaction. Now if I increase the pressure, what happens? Equilibrium will shift to the side with fewer gas molecules, meaning it will go to the left side, okay? Increasing pressure shifts the equilibrium to the side with fewer molecules, and it's important for you to mention that it is going to be either left or either right, okay? And then finally you write what is going to be produced. More reactants A and B will be formed. So for the same question, let's try to do for the decrease. So if the pressure is decreased, what happens? Okay, again, this is the same problem. So I have 2 molecules on left hand side, I have 7 molecules on the right hand side. So okay, so first things first, we try to write down that there are 2 molecules on the left hand side and I have 7 molecules on the right hand side. Now if I decrease the pressure, it shifts to the side which has more molecules, which is the right side, and that is why more products C and D will be formed. Now pause the video and try to fill up the blank on your own. Now I want to produce as much ammonia as possible, okay? So should I be increasing or decreasing the pressure? So what I would do is, give me a moment. Okay, so I have 4 gaseous molecules on the left hand side and 1 gaseous molecule on the right hand side, okay? So there are 4 molecules on the left hand side and only 1 molecule on the right hand side, and I want to produce ammonia, which is fewer gas molecules. So what should I do? I should be increasing the pressure, okay? It will shift the equilibrium of the reaction to the right hand side, which has fewer gas molecules, which is what I want, ammonia now, okay? Alright, but finally what I want to focus here is if you have the same number of gaseous molecules on both sides of the equation, such as this one, I have 2 molecules here, I have 2 molecules here, changing the pressure will actually make no difference at all. So in exams they will say that, oh, the pressure is going to be increased or decreased. You simply write there is going to be no change at all. Why? Because we have the same number of gaseous molecules on both sides of the equation. So whether you increase or decrease, the pressure is still going to be the same because you have the same number of gas molecules on both sides of the equation. Alright, so that's all for the pressure video, and in next video we will talk about changing temperature.